Hey everyone, thank you for the opportunity to share our work today with you. And first I want to talk about why we are doing this research. Imagine an officer stops a car to investigate if the driver is impaired and is the driver under influence of any alcohol or drugs. So the officer do this with performing roadside tests to investigate if the driver is impaired or not. And they use divided attention psychophysical tests, which are SFSTs. But if two officers can detect this impairment differently, if they can score the impairment in participant differently, how does this hold up at court for further investigation? So they need some evidence. My name is Saboora, and I'm a PhD candidate at SFU, and I'm working with Dr. Park at Vertex Labs. And today I'm going to show you how we remove this subjectivity of these tests by automating the test using video recordings of these tests. Yeah, thank you. So today I will cover this. Today I will cover these subjects to explain why we are doing this and to answer three main questions for developing this system. These three main questions are, what are these tests, divided attention psychophysical tests, and why we are automating them, we are proposing this system, and how we did it. And I'm going to talk about the results as well. In 2022, around 31% of fatal crashes in US and 26 crashes in Canada was due to impaired drivers. And impaired driving is really important in literature and in other studies, as well as in worldwide scenarios. And the impaired driving is really can cause fatalities and accidents in the roadside. So it's really important to investigate impairment in drivers as soon as possible. And DREs, or drug expert recognition officers, usually use SFSTs, or Standardized Field Sobriety Tests, to detect impairment in subjects in roadsides. SFSTs are really subjective, as I've explained before, and they are dependent on officers' opinion and qualifications. And it could be also challenging in remote access areas with no qualified DREs or trained officers. So our solution for this is to design an automated system to determine impairments in suspects or in participants using two main sets of tests of SFSTs, which are one-legged stand and walk and turn. So our system is like this. We use the cameras to record participants while performing these two tests before and after alcohol and drug consumption. And this device is built by our partner organization, Cancer Technologies, and we use the data that were collected during this test. And our overview system is that we use these recordings from this test. We after pre-processing and filtering, we extracted the most important features from the skeletons of the people in the videos. And after selecting the most relevant and important features, we finally classified the data to impaired and non-impaired in the participants. So what are these tests? The first one is walk and turn, WAT. As you can see here, in this test, the officer asked the participant or asked the suspect to walk for 9 steps, heel to toe, back and forth while maintaining their balance. And the next test is OLS, one-legged stand. In this test, officer asked the suspect to raise one leg from the ground, watch their raised leg, and count 30 seconds from 1,000, and keep their hands to the side and keep their balance while doing this test. So for developing this system, we used the videos of participants doing this test. First, we extracted the key points of the body. As you can see in this slide, we used open pose model to extract the key points. And because the distance between participants and the camera could be different while performing the test, we had to scale or normalize the key points using this formula. So this formula scales all the key points using the hip center as the reference point of the body. And then, so after extracting these key points, all the key points from each frame in the videos, we use the most significant features for classification. But here I want to show you what I mean by the feature extraction. No. Yeah, can you go back? Yeah, because I thought, yeah, sorry. So what I wanted to say that after extracting the key points, we have the scaled key points of all participants in all frames. But for the feature extraction stage, we use two main features. The first one is Euclidean distance between key points, between each key points, this Euclidean distance shows that if the participant can maintain their balance, for example, if they raise their hand to maintain their balance, keep their balance while doing the test, the Euclidean distance between some of the key points might oscillate. And the other feature that we use is balance ratio, which you can see in this equation. Balance ratio is also can help us to see if they can maintain their balance. And balance ratio shows the alignment between key point 1 and the hip center, which is like if the participant cannot stand in their place or they're just going back and forth or they're oscillating. So next slide, please. Yeah, this is what I wanted to show you. This is one of the results for Euclidean distance. I want you to see the difference between the sober person and the impaired person. This is just for one participant. And the Euclidean distance between key points 6 and 7, which you can see in this slide, it's the left hand. And the oscillation after impairment is really considerable, as you can see in this slide. And next, please. So after extracting these two main features from our participant and dataset, we selected the most important and relevant features using recursive feature elimination RFE method, as well as using ANOVA F-test score to score the features to just choose the best set of features for the final classification, and use k-fold cross-validation because we had a very small data set. And as you can see in this table, we used 4 well-known performance indices to compare our results. So the result for feature selection, as you can see here, this is the scores of ANOVA F-test score, and the OLS or OLS-right shows the highest score among all of the features, and this shows that OLS one-legged stand right foot shows the highest score and could be more useful in future studies. And also in walk and turn features, walk back shows the highest scores. So after selecting the most significant features from our dataset, we trained our classifiers and we compared these classification methods with each other. As you can see, random forest shows the best performance indices among all of these classifiers, and SVM also also shows promising results, which shows that these two classifiers can better distinguish impaired and sober participant. And in this figure, we also removed one set of data set to see which of these data sets are more important for our classification. As you can see, again, OLS one-legged stand shows better results, but if we use both of them, the results are good as well. So, in overall, as I've mentioned before, one-legged stand can better distinguish impaired participants and sober participants. Most relevant features are one-legged stand right features. This is when the participant is asked to be on their left foot and their right foot is raised. So we are assuming that, and we explain this as because most of our participants were right-handed and their left foot is their non-dominant foot. So when they were impaired, it was more difficult for them to maintain their balance. So that's why we think OLS-right foot shows better results and features. And also the performance of our classifiers is acceptable compared to officers' performance, which was 79 to 83 in walk and turn and OLS in literature. So to conclude, our proposed system shows acceptable performance, is objective, so it's not subjective. So we solve our first question, and it could be portable. We can use it in all stations. It's reliable. It's helpful for areas with less DRE access. And the scope of future work would be having more data sets as usual. And we want to have a substance-specific models for other drugs to see if the system works fine with them as well. And also we want to use CanSight mobile device, which could be used in roadside. And also another device that we are developing now, and I'm working on it, is wearable camera-free device, which uses biosignals to detect impairment in real time in people. So thank you so much for your attention, and I would like to thank our organization and funders, Cancer Technologies, MyTax, Vertec Labs, and SFU. And here's my contact information if you want to stay connected. And please let me know if you have any questions.